We will be heading to the planet Mars for our launch plan.
We are going to Mars because Mars is a great possible site for life because of the evidence that there used to be water on Mars and there is now frozen ice or frozen water all over the surface of Mars.
We will be doing a stationary lander type of mission. This is because we only need to identify one area of regolith.
We are searching for two different biosignatures, which are organic material and chemistry. We are searching for organic material because it may be show evidence of existing or past life, and we're looking at chemistry to see. We will also be looking at chemistry biosignatures because chemistry biosignatures will show us if there are chemicals such as oxygen or methane, which could give evidence that there's life on Mars because some bacteria produce methane, and oxygen is a building block for life.
We will be choosing the medium lift rocket A. This is because it is affordable and could carry the mass that we need to take up to Mars. It also has a pretty reliable takeoff plan.
We are using our advanced microprocessor for our computer system because it has more brain power than the other microprocessor, and it lets the spacecraft make simple choices without commands from Earth.
For our power system, we will be using the high power solar panels. This is because Mars is still within reachable sunlight, and we could use the solar panels to retrieve the sunlight and save it for night missions.
For our landing system, we are using airbags because the airbags will provide protection for our spacecraft and on its landing into Mars. And even though the airbags are not very accurate, we're not searching for one place in particular on Mars, so it doesn't really matter where we end up.
We will be using lots of scientific instruments on board. The first one we will be using is the atmosphere wind sensor, and this will collect detailed data about wind speed, wind direction, air temperature, and pressure. This could help us analyze the chemistry in the air.
We're also using an open path laser spectrometer, which will be able to detect localized methane emission and where it is coming from, such as bacteria.
We will next be using the impact probe. This will penetrate the surface at high speeds, which is good because lots of Mars is covered by hard sheets of rock and ice.
We're also using the hand lens imager, which can see objects as small as the width of 2 human hairs, and it includes UV LEDs to identify fluorescent minerals. And with the hand lens imager, it also needs to have the robotic arm, which is a great tool because it doesn't use much power and it's as a low cost.
Next, we will bring on board is a sample cache. This gives us up to 31 samples of soil, which is very important because we can collect lots of information.
We're also using a drill to drill into the earth, which provides an added science point.
Next, we will be using the rotating instrument mount. This is beneficial because it gives our robotic arm a lot more mobility. It will also give us a science point.